In the previous episode, the students used data from 1961 to 1990 to create a function that gave the average maximum temperature. In this episode, they will create a model for the average maximum temperature using averages from 1991 to 2010. After they have done so, they will compare the two models.
They're super similar. They're not the same. Like, you can tell that
it's gone a little bit
this
more,
30-year average has kind of like increased in general,
but
it's the same curve. We said that K was the annual average, and A actually is still 27.
Yeah. Wait, let's
yeah, because
see.
it's close to the same, because 75.2 minus 22.4. Well, let's just do 75 minus 22.
52.8.
Which is,
Yeah, that will work.
27 is close to the middle. Because you also have to, like...
What would be a little bit more accurate than 27?
It wouldn't be 27. We'll just do divided by 2. Look, go back on your calculator, divided by 2.
Did you say 52.5? Is that what you said?
50-something point, yeah. Divided by...
26.4. Let's do 26.5.
Yeah. Maybe. There.
There we go. Yeah. Wait, why isn't P shouldn't it be 12?
Oh, yeah. Why did it go up?
Yeah.
12. There.
See, now it matches down there a
Yeah.
little bit better.
I see.
The equation the students developed based on the 1981 to 2010 data is y equals 26.5 times sine of 2 pi over 12 times x minus 4.1 plus 49. The equation the students developed based on the 1961 to 1990 data was y equals 27 times sine of 2 pi over 12 times x minus 4.1 plus 48. Take a minute to compare these two equations, and then watch Mary and Claire discuss their differences.
So how does your left graph, which is the older graph, compare to your more recent graph in terms of time?
Oh,
Our recent one is just higher.
A little bit higher.
Has a smaller average.
yeah.
Like,
It's our average is 52 instead of being 55.
Instead of being 55. Okay, so where do you see that average, like, where do you see those averages in those functions?
like, well, here, I'll use this. Like,
What I mean is like circles. So you're saying like your average is A.
well, half of the
Oh, I see.
half of the difference between the maximum and minimum.
Half of the difference between the maximum and the minimum. I see.
So they're just slightly off. Like, this one is 27, I'll write it bigger, and this one is 26.5.
What about like the 48 and the 49? What are those representing?
They're like the annuals, the approximate annuals, because like you can't get like 48.9 on this one, but like the annual average temperature.
The annual average temperature. And what's the difference between the newer and the older?
The newer one is 1 more than the older one.
One more. So on average, we're looking at like a degree change
Yeah.
from when to when.
Like, this one had a higher degree change, like the degrees here started higher than the ones here.
I see.
In this episode, Mary and Claire developed an equation that gives the average maximum temperature as a function of time based on data from 1981 to 2010. They then compared this to the previous equation they had developed. They found that the A values and the K values were different in their two models. They interpreted these differences as their model suggesting that while there was less variation between the hottest month and coolest month during the later time period, the temperatures tended to be a little warmer during this period. In the next episode, they will extrapolate from their models to predict how average highs might change over the next 30 years.